Steve, take it away.
All right, great. So let's start this. So from what I understand, I have to click on some buttons to make you able to see my screen. So I'm doing that right now. And then hopefully you can see my screen. And if you can't, then somebody better do something to interrupt me. So let's start this session. Thank you for choosing to come to this. I'm really glad that you are choosing to spend a bit of your time on this session. So my name is Steve and I work at Microsoft on the ASP.NET Core team. And my focus is on Blazor. I've been doing this for 2.5 years now, so quite a while. And in this talk, I'm quite excited to show you some of the things that we're thinking of doing next or pretty soon, or maybe a little bit further off in the future. Now, this talk is going to be a little bit more aimed at more advanced scenarios than the one that Dan just did. So if you are new to Blazor, there may be aspects of this that are not familiar to you, but don't worry, I will do my best to give you some of the background as we go. But if there are parts you don't get, well, never mind. There are lots of other talks that will give you more of introductory stuff as we go. So what I want to do with this talk is start with an existing Blazor application, an application that we've had around for a little while, and I'll show you how we could add some cool new features to it using things that we've not actually shipped yet but are thinking about doing. Okay. Now, the application that we're going to be using in this talk is a sample application called Flight Finder. And some of you may well have seen this before. It's been around for quite a while now, from pretty much the beginning of the whole Blazor project. And if I start that up, then hopefully you will be able to pick up on what it is pretty quickly. So it's an example of a site that people could use to search for and book flights. And it's built as a pretty standard Blazor WebAssembly application. So our user could come along and they could say something like, okay, I'll use this autocomplete thing and I want to go from Tokyo's Haneda Airport, and let's say I want to go to Paris Charles de Gaulle, and I would like to fly there this coming Monday, and I would like to come back the following Friday. And since this is entirely fictional, I might as well, in my imagination, go first class. And I'll hit the search button, and that will go off to the server, and it will get a set of flight data results back from the server and display them. Now, this is not real data from an actual flight database. This is just random data that the server comes back with. But that's not really the point of this talk. You could implement that sort of logic on the server if you wanted. We can also change the sort order between the cheapest or the quickest, depending on which we prefer. And when the user has found some flights that they like, they can click on this add button and add them to their shortlist and maybe compare this relatively cheap flight versus this much more expensive one. Okay, so that's what the UI looks like. Now let's have a little bit of a look at some of the code behind there. So in the solution, you'll see that we've got 4 projects, and I'm only actually going to talk about 3 of them right now. We'll start with this flightfinder.client. That is a normal Blazor WebAssembly application. So this application is composed of various Blazor components, each of which is one of these Razor files. You saw a lot of those in Dan's talk just a minute ago. And we've also got bits of C# source code that implement various other things. We'll talk about that in a minute. And that is compiled to normal .NET assemblies, and then it's sent down to the browser and it executes on WebAssembly inside the browser using the mono WebAssembly runtime. And we've also got these other projects. We've got flightfinder.server, and that's the server-side component of our application, which has got some MVC controllers in it, and they are responsible for serving data back to the client in JSON format whenever the client asks for flight results and things like that. And then finally at the bottom, we've got this shared project, flightfinder.shared, and in that project we can put any code that we want to share between the client and the server. It's a normal class library that both of those other projects can reference. And so we've got various domain types in there. For example, airport, and we're defining that an airport is something that has a code and a display name. We've also got, for example, search criteria, and that's got all these properties where you're going from and to, and what dates you're traveling, and what your ticket class is, and things like that. Okay, now let's have a look at how the Flight Finder itself, the client, is built. Well, the best place to start with that is this component main.razor. That's the top level root component for the application, and that imports our other components, such as search component that's up there at the top, And below that, we've got search results. And over on the right, we've got this shortlist component where the user's selections show up. And then the other interesting thing is we've got this app state concept. And in this application, app state is a regular C# class that's implemented over here. And this contains a lot of the actual state management within the application. So we've got what are the search results we're displaying, is there a search in progress, and things like that. And it's also responsible for making requests to the server. So when you do a search, it's going to use HTTP client to post a JSON request to the server, sending your search criteria and get back an array of itineraries. So that's all very well. But this form of JSON-based data access has got some drawbacks. Let's think about those. So let's see what happens in our browser when we hit the search button. Well, what we see is that we make a request to the server, and it goes on this particular URL, API/flight search, and we hard-coded that into our application here. It's also a post request, which was also hard-coded in, which is all very well, but how do we know that that's really right? How do we know what the right URLs for things are? There's nothing to check at compile time that we've actually got correct URLs. Another drawback to this form of data access is that the data that we're sending is very verbose because it's all in JSON format. So here you can see the payload that we're sending to the server, this very verbose text-based JSON data, and the response that's coming back is also JSON data, which is not very efficient on the wire. So considering these two drawbacks, the fact that we have to hard code lots of assumptions about URLs and things, and that it's not very efficient on the wire, you might think, well, could there be a more efficient, more modern alternative to sending JSON over these unstructured URLs? And the answer to that is yes, there's lots of other alternatives to that. And one of them that's been gaining a lot of traction recently is gRPC. gRPC is Google's remote procedure call mechanism. And for the purposes of the application we're building, we can think of it as being just an alternative to sending JSON over HTTP. And the ASP.NET team did quite a lot of work during the 3.0 release to add very, very good support for gRPC on the server. So we can use that with server-side ASP.NET Core. One of the advantages is that it's designed for performance. So unlike JSON, it sends compact binary data over the wire. So your amount of bandwidth used will be much less. And also, it's designed to be language agnostic. So when you design a gRPC service, you define a language agnostic proto file. And that then can be compiled or generated into strongly typed server and client classes that are used from different languages. And that guarantees that the server and client are in sync, and you don't have to have things like URLs. Now, the other really great feature of gRPC is that it's not REST. So you don't have to have arguments with your coworkers all the time about what the right HTTP method is for something and what different HTTP status codes are supposed to represent, because none of those concepts exist. It's just a much simpler, more low-level RPC mechanism. Now, traditionally, it's not been possible to use gRPC from browser-based applications because it relies on HTTP 2, and JavaScript doesn't expose any APIs for HTTP 2 features. But that is changing because gRPC Web is an extension to gRPC that makes it possible to run it on normal HTTP 1.1 connections, so you can do it from browsers. And James Newton-King from the ASP.NET team has been hard at work creating a set of prototype packages that add gRPC Web support to ASP.NET Core on the server, and they also work with Blazor WebAssembly on the client. So let's have a go now at changing Flight Finder so that instead of JSON, it's working with gRPC data. Okay, so let's go back to our source code and have a look at this Flight Finder shared project. And you'll notice that all these different domain classes have been written by hand, okay? And it's going to be a little bit different when I switch over to a gRPC-based solution. Now, I don't have time to show you all the steps involving switching to gRPC. I'm just going to show you the result of doing so. So I'm going to switch over using my Git client to check out a gRPC version of my application. So what's changed then? Well, now you'll see that inside my shared project, I've got this file, flightdata.proto. And if I open that, you'll see this is the language-independent definition of the gRPC service. I've got this service flight data, and I've defined a couple of endpoints on it, airports and search. And these define what data the client will send and what the response type from the server will be. So in the case of getting airports, we don't send any data. We send an empty request from the client to the server, and it replies with an airports reply. So what is an airports reply? Well, that's defined here. And you can see that it contains a repeated collection of airports, and each airport is something that has a code and a display name. Similarly, the search takes a search criteria and it returns a search reply. And those things are defined down here. So you can see search criteria has got all these properties on it that you would expect, and search reply has got our itineraries, and they're all defined. So there's quite a lot of stuff going on inside our proto file. And the cool thing about this is that the tooling in ASP.NET Core will generate .NET classes for us from this. So I don't actually have to write an airport class. That's just going to be generated for me. Same with all these other types of things like search criteria and itinerary and so on. Now you might think a drawback to generating this code is you can't really customize it, but you can, because if you want to add some extra properties to these generated classes, you can easily do so because they're partial classes. For example, on this itinerary class here, you'll see that I've added an extra partial class for itinerary in which I've been able to define some extra properties. For example, I've defined total duration hours, which is computed by adding these other two duration hours together. Okay, so now I've got that, I can use this to expose a gRPC service from my server instead of needing MVC controllers. And that's what I've done here. And I'm not going to really get into how that works because that's just standard server-side gRPC, and you can read docs about that. The more interesting things for us right now is what does it look like to consume that in a WebAssembly Blazor application? Well, the way you would do it is, since you've also got a reference to this shared project, you've automatically got access to all the classes that have been defined, that have been generated from the proto file. So we now just have to access them. And the way I'm doing it is defining a dependency injection service. So here, if you know about Blazor, you'll know we generally on the client have a startup CS class in which we can configure any services that are available in the application. And here, this block of code, which I know you won't necessarily understand all of, the important point is that it defines a flight data client. And I don't have to write any code for flight data client. That's generated automatically from the proto file. The only thing I have to specify is what's the URL of the backend server that it should connect to. And what I've done here is I'm using this navigation manager service to say that the URL is just whatever URL the browser is currently on, because I'm hosting my UI on the same server that I'm hosting the gRPC web backend. So that's what this complicated looking code actually does. Okay, and now inside my app state, when it comes time to request some search results from the server, I'm not using HTTP client anymore. I'm now using this flight data client service, which has been code generated and injected through DI. And I can just call a strongly typed method on there like search async, pass some criteria to it, and get back itineraries. And I don't have to specify a URL or an HTTP method or anything like that. It's all just sorted out for me. So let's try that now. I'm going to run that in a browser again, and we'll see if we can really consume gRPC services from a Blazor WebAssembly client. Okay, so what happens now on the wire when I click on search? Well, first thing to note is that hopefully we did actually get some results back from the server. We did. And then if we look inside the browser's network tools, you will see that what we did now is we made a request to a URL that is determined by gRPC. We don't have to decide it ourselves. And the data that's been sent is not JSON anymore. It's now this compact binary data that we can't really even read. There is actually a text-based format for it if you want, but it's more efficient to use the binary format. And the response that comes back is also binary data, which is efficient on the wire. And we didn't have to say anything about URLs, so we can be certain that the client and the server are always talking the same language. Okay, now to give you a little bit more of a sense of how this works out, let's have a go at adding an extra gRPC endpoint and calling it. So let's say that I want to keep track of what things people put in their shortlist. So when I click this add button, I want to tell the server that the user has added something to their shortlist. I want a way of tracking it on the server. So to do that, I'm going to add an extra gRPC endpoint that the client can send a message to. So I'll go to my proto file and I'll go to the list of services, and I'm going to add a new one here called add shortlist item. and it will take an itinerary, and it doesn't return anything because we're just sending data to the server there. And now on the server, I can go to my flight service, and you see it inherits this flights data base class, which is automatically code generated for us. And so now I can try to override this code generated method called add shortlist item, and I can put in whatever server-side implementation I want. And in this case, since it's just a demo, all I'm going to do is log the fact that this method was called to the console, so we can see that the server really got that message. Okay. Now the last thing to do is to actually call it from the client. That's very easy. I can go to my app state class here, and this is the method that gets called when the user adds stuff to the shortlist. So what I'm going to do is I'm going to change it to be an async method, because all client-server communication is async, and then I'm going to say await flight data client dot add shortlist item async, and you can see that that's automatically shown up in IntelliSense because of the code generation, and it takes an itinerary, so we'll pass the one that's being added, and that's it. We're done. Okay, let's try that out, shall we? See if we can really call this new method from the client. So that comes up, and I want to show you what comes up in the web server's console output, because that's where we're logging this. So now, back in the browser, when I click on this search button, you will see in the background immediately, when I click the search button, the results appear below, but when I click the add button for this $1,100 flight, then immediately in the console output, you'll see the server receive this message, adding to shortlist the $1,100 item. So it was absolutely trivial to call this method on the server from the client with this very efficient binary data on the wire. And that's the cool thing about using gRPC. So that's all I'm going to say about that. I want to move on to another interesting future feature that we're thinking about. And this one is to do with testing. So when you're testing Blazor components, as it stands today, you've basically got two choices of how to do it. And this is true pretty much for all web-based UI when you want to test it. You could either write unit tests with something like XUnit or NUnit, and that allows you to write tests that operate at the level of .NET objects. So that can be very fast and very robust, but it's not talking about the rendered HTML. It's just talking about the actual code representation, the actual .NET code. The other approach that you could use is a browser automation approach. And that would use something like Selenium to start up an actual browser instance and then automate the action of clicking on buttons and making assertions about what gets rendered into the UI. Now that's nice because it's very high level and lets you talk about the actual HTML elements and click on them and things, but it can be slow because it's automating a real browser, and it might not be so reliable because unless you're very careful, you end up making assumptions about the exact timings of renderings and things like that. So that made us think, well, is there some way that we could offer the best of both worlds when you're testing Blazor components? Could we somehow give you the speed and robustness of pure unit tests by not using any actual browser and letting you still work with the underlying .NET objects and mocking out DI services and things, but combined with the benefits of browser automation so that you can make assertions in terms of the rendered UI with the HTML elements, with CSS selectors and so on, and do simple things like clicking on buttons and making assertions about what happens. So that's something that we've been working on producing a little proof of concept for. So I'm going to show you an example of how we can do that for our Flight Finder application right now. So what should we write a test about? Well, with this test prototype, we can write tests either about individual components or about the whole application. And I'm going to start by writing a test about an individual component. And the one I'm going to write a test about is this shortlist component over here. And you can see that it starts out empty, saying 0 items, and then we add stuff in, and they show up both in the title and with this complicated markup down below it. So let's write some tests to make sure that this is behaving correctly. And that's why I've got this project flightfinder.client.test, and I'm going to add a new test class into that. And I'm going to call it shortlisttests.cs. And I'm going to just paste in a little bit of code that I've already prepared. So what it's going to look like is this. And I'm using XUnit, so that's what this fact attribute is about. And I want to assert that initially it's empty by default. So what would that even mean? Well, let's have a look at the source code for our shortlist component. You can see that what it does is it receives a parameter from its parent, which is the list of itineraries that it should display. That's the things in the user's shortlist. And at the top, it's got an H2 element that displays the count of that collection. And then below that, it's got a for each loop that loops over all the itineraries, and for each one, it creates one of these unordered list elements, and it's got a massive block of markup inside that. Okay, so let's write an assertion that is initially empty. Well, first, how do we get an instance of our shortlist component that we can render? Well, using this test framework, we can create something called a test host, and then using test host, we can say, please create an instance of the shortlist component. Again, strongly typed. And simply by doing that, we can then make some assertions about what UI it's rendering. So we can say there should be an H2 element, and the text on it will say shortlist 0. And if we look for some unordered list elements, well, that set will be empty. There's nothing in it because we haven't got any shortlists to render just yet. So let's try running that, shall we? If I go over to the Test Explorer in Visual Studio, then when it updates after recompiling, then we'll see that we've got one test in there right now. And if I hit the Run button, it's going to compile stuff, and we'll see that initially everything goes green. Can display empty test has passed. So that's great. Okay, now let's add a test to do something slightly more interesting. In fact, let's do a little bit of sort of test-driven development in a sense, because there's an aspect of the behavior here that I'm not very happy with. I'm not very happy with the way these prices are being displayed. I think it's pretty ugly that as well as showing the dollar amount, we're also showing the cents. That's pretty strange. No one really cares that there's 15 cents there. I would like it to round these numbers to the nearest whole dollar, and I want to design that using tests. So how can we test that? Well, we'll start by making a test method, rounds prices to nearest unit, and I'm going to create an instance of the shortlist component, but this time instead of being empty, I'm going to pass a parameter to it to say that I want it to have these two itineraries in there, one for fake airways, one for test airways, and they've got different prices. And then I can write some assertions about the rendered UI. First, we'll assert that the shortlist should have two items in it this time, because that's what we've passed. And then we'll write assertions about how they're rendered. We'll say the one for fake airways should say $123, because we're rounding down 123.45. And then the one for test airways, which is 456.78, that should be rounded up to 457. Okay, now we can run our test and we'll see if it actually passes. And we know it shouldn't pass because we haven't actually implemented this rounding behavior just yet. So if we run it, you'll see the test initially fails. And if we ask, why has that test failed? Well, let's see what the assertion was that failed. It's kind of hard to see with the screen resolution, but you will see that we expected it to display 123, but it actually displayed 123.45. Okay, so we know how to fix that, right? We'll go to our shortlist component and we'll find where the price is rendered, and it's rendered right here. We've hard-coded a dollar symbol, and then we've just got the price. So that's not a great way of writing this code, because in .NET there is a proper way of formatting currency values, like this. We can say price.toString, and then we'll give the format string C, and that means render it as a currency value, and I'm going to put 0, which means 0 decimal places. And then simply by doing that, I can run this test again, and we'll see if it changes from failing to passing now. It has to recompile everything, and hopefully it will run. And this time, instead of failing, you'll see it's now passed. So we've got our test actually proven to work. And if you want to, we can even run it in a browser. And so now when I add stuff to the shortlist, you'll see it's rounded to the nearest whole dollar. Okay, so that's better. Right. Now, I said that we can write tests not just for individual components, but if we want, for the entire application. And we can do that pretty easily because the application itself is just a component. You remember that we've got this main component at the top level, which has got everything in it. So I can write a test for main, and then I can test things like how data flows between one component and another. So what I want to write a test for now is something to do with the user experience around searching. There's a bit of a problem with the UX at the moment, which is that when I click this button, there's no indication that we're waiting for data to come back from the server. Just nothing happens until the data comes back. And that's not great because the user doesn't know whether the data we're showing here is stale data or whether it's actually the up-to-date data for their new search. So the way I want to fix this in the UX is that I want this whole bottom left portion of the screen to be grayed out while we're waiting for search results to come back. So you click search, it gets grayed out, and then the data comes, and then it becomes not grayed out anymore. It's a fairly complex interaction, so I want to specify it using a test. So I'm going to create a new test class here, and I'm going to call it search flow tests, okay? And it's going to be about stuff to do with searching. And again, I'm going to drop in a little bit of code that I've already prepared. And there's a little bit more code this time. So let's see what's going on here. So like before, we're using test host, but unlike before, I'm creating a test version of the flight data client. And that allows us to intercept any requests that the component tries to make to the backend server so that we can mock that out and return fake data to simulate different conditions. And then down here, I'm adding all these services to the test dependency injection container so that the component will actually use them. And then finally, I'm ready to write a test. Okay, so I want to test that we gray out the search results while we're loading. And to do that, I'm going to create an instance of the main component, and then I'm going to define what it means to be grayed out. So I'm going to say that things are grayed out if the results area has got this CSS class gray out on it. And then I can write an assertion with that. I'll say that by default, initially, we are not grayed out. That grayed out is false. And we expect that test to pass because we're not graying anything out just yet. So if we have a look now, we've got our search flow tests, and I can run that. And what we should see is that that test goes green, it's passed. Okay, now let's go a step further. Let's say that now, when we're searching, we should be grayed out. So we'll find the submit button for a search and we'll click it. And at that point, is grayed out should become true. And then even more clever still, we'll say, we'll simulate the flight data client sending back a response from the server. And at that point, we should not be grayed out anymore. Okay, so that's the entire flow of interaction. And I'm going to run the test again. And hopefully this time it's going to fail. Okay, and it does fail. And we see the assertion that failed is this one on this line. It didn't become grayed out. And that's not surprising because we didn't implement that yet. How can we implement it? Well, it's pretty easy. I'm going to go to my main component here. And then on this results area component element, I'm going to add a conditional CSS class. And what it's going to look like is this. I'm going to say, if the search is in progress, then we'll have the gray out class. And if not, we won't. And that's all there is to it. So now when I run again, hopefully that test that was failing before should now go green, and we'll know that we've implemented this behavior correctly. So wonderful. And if you want to see that for real in a browser, I can come back and you'll see that now, whenever I click search, that bottom portion becomes grayed out. At least I hope that's coming through on the stream for you. All right. So that's about testing. Right. Let's move on to the last major area that I'm going to be talking to you about. So far, we've been running all these applications inside browsers. Dan gave you an example of a Blazor server application that runs in a browser, and I've been giving you an example of a Blazor WebAssembly application that also runs in a browser. But what if you didn't want to run in a browser? What if you wanted to make an installable desktop application so that the user can have it on their start menu, their app home screen or whatever, and they can perhaps integrate with the operating system? Well, traditionally, there have been two ways to do that. You could make a progressive web application, or a PWA, and that's great because it's very lightweight. It installs from the browser instantly, and it's immediately available on the user's device. But it's not so great because it's still running inside the browser sandbox, so it doesn't really have any native access to the underlying operating system. You can't put native code in it. And if you do want native code, you would traditionally use something like Electron, which does give you the ability to integrate with the operating system in whatever way you want. But traditionally, Electron apps have been quite heavy to download and run. And that's mainly because they bundle their own complete browser instance. So again, that had us thinking, is there some way we could create the best of both? Could we make something that's lightweight to download and run, but also allows you to write native code? So it isn't subject to the browser sandbox, isn't running on WebAssembly, it's running native code. And that brings us to this experiment called Web Window. Okay, let me show you how we can use it. Let's say we want to create a native desktop version of our Flight Finder application. And I'm going to do that by adding a new project. And I'm going to choose a C# console application. You might think it's a bit strange that I'm making a console application, but just bear with me for a minute. And I'm going to call it flightfinder.desktop. Okay? And when that is created, it will be a normal console application. And you know what these things look like, right? It's going to display hello world. So if I run it, then I'm just going to get this black screen that says hello world. All right, so that's all very well, but I don't want to create a text-based application. I want to create a proper graphical application. For that, I'm going to use this web window package. So first I have to add a reference to it, and that's going to look a little bit like the following. Here we go. Here's a reference to the web window package. You can see it's a preview or purely experimental package. And once I've got that, I can use it. So I'm going to say var window equals new web window. Okay, need a namespace. And I'll give a name to my window or a title. I'll call it My Cool App. And then what can I do with that? Well, the simplest thing I can do is navigate to string. And I can give some HTML markup. So I'm going to say, hey there, this is nice. All right. And then I'm simply going to wait for the user to exit the application. So all being well, when I start up my console application now, you will see that it brings up an actual graphical window, and it's going to use browser rendering technology to render this. So unlike an Electron-based application, this is not bundling its own browser. This is using whatever browser technology is present on the operating system that I'm running. And it works on Windows, Mac, and Linux. It's very lightweight, and it still gives us the ability to do browser-based applications that are still installable. Okay, now I don't actually want to hard code some HTML. What I want to do is host my entire Flight Finder client application inside here. And that involves about 5 steps, and I won't have time to show all of them to you right now. So what I'm going to do again is I'm going to switch to a different version of my repo here that's got the hosted Blazor application inside Flight Finder desktop. Okay, so what's different? Well, what's different now is that I'm referencing webwindow.blazor, which is a version of the web window experimental package that knows how to host Blazor applications. I'm also referencing my Flight Finder client project because that contains all the components I want to run. And finally, I've got all this MS Build goop down at the bottom, and that knows how to copy all the necessary static assets for CSS and fonts and things into the desktop publish output, so that when it's published, it produces a self-contained runnable application. Okay, so if I run that, let's see what happens now. When I run it, what should come up is a Flight Finder titled window, and inside there, we've got the actual application. And it works. I can run it, and I can get my data back from the server, and I can add stuff to the shortlist, things like that. Now, you might be wondering, did I have to change a lot of stuff to make it run inside web window? The answer is no, I didn't have to change anything apart from one little thing. The one little thing that I had to change, and I'll show you, is on the startup class, I had to change the URL that we're talking to the backend on. So normally we would get it from the browser, but when we're running in desktop, we don't have any particular browser, so I'm getting it from a config file here. So I've got this config file, appsettings.json. Okay, so that's the only change I had to make. Okay, now, since .NET Core itself is cross-platform, and Blazor is cross-platform, and Web Window is cross-platform, that suggests that we should be able to run this application on other operating systems as well. And so I'm going to show you that. Over here, I've got a Mac, and I've cloned the same repo onto the Mac. I didn't have to change it in any way. And because all this stuff is cross-platform, I can say .NET run. And that's going to compile the same application. And when it runs, it's going to show up on the Mac as a native-looking application. And it works. Well, it kind of works. There's one thing about it that's a bit weird. When I go to the Alt-Tab window, you'll see I've got this really ugly console application icon. And that's because the operating system still thinks that this is a console application. But I want to make a true self-contained Mac app bundle that could be distributed to other machines and installed and have a proper icon and such like. And it's quite easy to do that. And I've made a little script that does it, and you'll be able to see this when I publish this repo. That's going to publish a self-contained version of the application, and it converts it into a Mac app bundle with an icon and puts it on the desktop. So you could make this downloadable, you can copy it into your applications folder and such like, and you can simply double click on it and it shows up, and we see we've now got the application coming up and we've got a proper icon for it, and it's really, as far as the user is concerned, exactly like a regular Mac native application with the same code that also runs inside the browser on WebAssembly. So that's all I'm going to have time to show you. One last little thing that I'm going to go through in the next couple of minutes is a very quick update about Blazor WebAssembly application sizes. And I'm bringing this up because a bunch of people have been asking questions about this lately, and I want to give you a sense of where we're going. So when you create a Blazor WebAssembly application today and publish it, the downloadable application size is just over 2 megabytes. It's 2.05 megabytes, and that is some of that is the fixed mono WebAssembly runtime that's common to all apps, and some of it is your own application code and your own .NET assembly dependencies. Okay, so we've done a lot of work to bring it down to just about 2 megabytes, which is kind of impressive that we've got a whole .NET runtime there, but it's still pretty big, and we want to find ways of making it smaller. And we've done some work in the current milestone that is going to bring it down a little bit. When you first see this chart there, you probably think, whoopie-doo, that's not a very big improvement, is it? You've reduced it from 2.05 megs to 1.9 megs. Well done. But it's slightly better than it looks. What we've done in this current release is we've enabled the linker to strip code out of the Blazor framework assemblies, as well as the underlying .NET base class library. And the benefit that we're going to see from this is that as we add more and more features to Blazor in the future, it won't make applications bigger. We can add as many features as we want, and as long as you're not using those features, you won't pay any cost for them. Okay, now, going forwards, we've got a goal of making it a bit better still. And our target for our initial May release of Blazor WebAssembly is to get down to under 1.5 megabytes by default. And we've got a way that we think we can do it. And the approach that we're planning to use is introducing some more aggressive pre-compilation. This will happen during the publish phase of the application, so you won't see it during development. But when you publish, we'll spend about 20 or 30 seconds doing some very aggressive compilation, compression on the artifacts that are produced. And we believe, or our proof of concept shows that that gets down to just under 1.5 megabytes. And there's no real drawback to doing this. It doesn't make things take any longer when people run it in their browsers. It just makes it less weight on the wire. So this is strictly a good thing. It doesn't cause you to lose any features or anything. So hopefully that is something that we'll be able to include in the May release, and that improves things. And I'll just remind you that these numbers only refer to the first time a user goes to your site. Everything is cached, so when someone comes back for the second and third time, they are not really paying the cost to download any of this stuff, because it's all cached already. These numbers are just for the first ever visit from a given user. Okay, so that is all I'm going to have time to show you. In summary, we took an existing Blazor application, Flight Finder, and we improved the way it did data access by changing over to gRPC. We then added some tests using the prototype testing framework that showed you how we can get the sort of benefits of browser automation combined with the benefits of pure unit tests. And then finally, we turned the whole thing into an installable desktop application in just a few minutes, and we showed that that could run cross-platform. So I hope that has been of some use to you, and I hope that some of that has been exciting. I'll encourage you to stick around for some of the other great talks that happen later in this conference. And for now, I think I will see if there are any questions that I'm able to answer. So how do I do that?
Hey, Steve, thank you so much for your presentation. We actually do have a time for 2 questions.
Yeah.
Let's see, can we put them up on the board here so we can look at them? Okay, question number 1 is, hey, Steve Sanderson, I tried Web Window today, but was not able to use external Razor class library in it. Can you please share the Flight Finder desktop code? Would like to see more code on it.
Yes, I will definitely share the repo that I've been doing all the demos from today.
Perfect. And one of the things to mention along with that is we're going to gather all the repos from the speakers and we're going to put them out on GitHub so people can look at them after the conference as well. So we'll start doing that with these sessions. We have another question here. Will Blazor native UI be able to access the computer's hardware? I'm thinking of IoT apps that will need to read and write to a serial port.
Okay, so with the web window demo that I just showed, that was not running on WebAssembly. That was running native .NET Core code, which can directly access any API from the underlying operating system. So yes, you can absolutely access whatever you want there. There's a different approach to writing native Blazor applications, and that is the mobile bindings for Blazor that is going to be shown by Elon in one of the talks later today. That's a whole different technology stack, but that also gives you a way of executing Blazor applications on the bare metal of the operating system. That one's more focused around mobile, but that also can do what you're asking there. So yes, there are certainly ways to do that.
Perfect. Thank you so much. Well, everybody, I'd like to thank Steve for taking the time. He couldn't make it into campus today, so that's why we had to do a Skype call. So thank you so much, Steve, for taking the time out of your busy schedule to speak with us. We have Chris Sainty coming up after a quick little break here as we get him called up, and we'll be right back with more .NET Conf Focus on Blazor. Thank you.